Dear students, in this lecture we will discuss the extraction of lanthanides in detail. The mineral, the deposit of lanthanides occurs in monazite. The monazite is a heavy dark sand found in Brazil, India, Australia, South Africa and United States. This monazite is concentrated, then the mineral is extracted, then separated. How extraction is done, why this extraction is expensive, costly. The composition of monazite varies depending on its location, but generally contains 50% lanthanide compounds by weight. All lanthanides have similar properties, so usually occur together in nature. The separation and purification of lanthanide requires considerable effort. Due to this considerable effort, the extraction or production of lanthanide tends to be expensive, costly. How extraction of lanthanide is done from monazite mineral? We know that monazite is chief mineral from which the lanthanides are extracted. The lanthanides are obtained as byproducts during the extraction of thorium from monazite. It means the extraction of thorium from monazite results, in addition to thorium, the lanthanides as byproducts. Following operations are to be done in the extraction process. Concentration of the mineral. Monazite is separated from other impurities by using the willfully tables, the shaking tables. The monazite sand, being heavier, get caught upon the riffles, groove, while the remaining lighter material get washed off. This heavier portion is then subjected to magnetic separator, whereby the monazite, being less magnetic, gets separated from other magnetic material. At the end of this separation, the separation means on the end of this step, the concentration of mineral, a refined monazite, from which most of the impurities have been removed, with a rough composition of thorium oxide 7.5%, cerium oxide 30%, phosphorus oxide 29%, and silicon oxide 1.5%, and 32% of other rare earths is obtained. It means the first step is the most important step, in which the monazite is concentrated. How concentrated? We have discussed here by using the shaking tables, then by using the magnetic separator. Next step is cracking, processing, or opening of the mineral. Opening of the mineral means the removal, the extraction of the desired component from the ore. This chemical treatment may be applied by either acidic method using sulfuric acid or alkaline method using NaOH. How acidic method is used? In this method, refined monazite, which has been obtained by concentrated process, is heated with 93%, means concentrated sulfuric acid, at 210 degrees Celsius in cast iron vessels, having mechanical stirrers, mechanical mixers, stirrers. In this process, after 4 hours, a viscous paste is obtained. Sometimes we say this viscous paste a mud, M-U-D, mud. This paste contains sulfates of lanthanide and thorium, This paste is leached with water, shaken with water, mixed with water for about 15 hours when all these sulfate go into solution. Only insoluble sand, SiO2, unreacted minerals and traces of titanium oxide and zirconium sulfates are left behind. It means these are the residues. And the soluble portion goes into filtrate, the filtrate which pass on the filtering medium. This residue is then crushed and returned for recycle. The leach solution in acidic because of the formation of the leach solution is acidic in nature. Why it is acidic? Due to the formation of phosphoric acid as shown in chemical equation. P2O5 plus 3H2O form the phosphoric acid which ionizes as shown here, 2H plus and 2H2PO4 minus. This solution is treated with sodium pyrophosphate. Why treated with sodium pyrophosphate? To precipitate the thorium as thorium pyrophosphate. Now, this thorium pyrophosphate is separated as a residue. The remaining filtrate is treated with oxalic acid to precipitate a mixture of oxalates of lanthanide and little amount of thorium and zirconium oxalates. It means the filtrate is treated with oxalic acid to precipitate them as oxalates because their oxalates have least solubility. This mixture is then boiled with ammonium oxalate to dissolve the thorium and zirconium oxalate. The residue is then ignited, heated at very high temperature, burnt. The residue is then burnt, ignited at high temperature carefully with concentrated sulfuric acid. Sodium sulfate is added to the clear solution of sulfate of lanthanides. So the lighter lanthanides having atomic number 57 to 63 precipitate as double sulfates, while the heavier one remain in the solution as single sulfates. The addition of hard sodium hydroxide to the precipitate yields a mixture of the hydrated oxide. Now, this fraction is dried in air at 100 degrees Celsius. We get mixture of oxides of lighter lanthanides with a rough composition: lanthanum oxide 17%, cerium oxide 5%, and Pr2O3 8%. Neodymium oxide, samarium oxide, and little europium oxide. Here we get from the mixture which have been dried at 100 degrees Celsius. Extraction of cerium. How cerium is extracted? When this mixture is treated with dilute nitric acid, all lanthanide oxide except that cerium get dissolved. That means the cerium oxide does not dissolve in the mixture upon adding of dilute nitric acid. The residue cerium dioxide is dissolved in 85% nitric acid to make crude cerium nitrate, which is further converted into red basic nitrate, having the formula as shown here, by reacting with dilute sulfuric acid. The solution containing nitrate of the remaining lanthanide is then subjected to different methods for further separation. We know the different methods: fractional precipitation, fractional crystallization, selective oxidation reduction method, other chromatographic techniques, solvent extraction techniques. The solution containing heavier lanthanide is also similarly subjected to different methods for separation of individual lanthanides. Now the next method is alkaline method using NaOH. How? This method is used for the separation of lanthanides. The cracking of onazite sand, which contain the lanthanide, can be proceeded by using the alkaline method using sodium hydroxide. Here is the flow sheet which can explain how the lanthanides are extracted by alkaline method. Here, check here, monazite sand. Now 74% NaOH is added and heated at 40 degrees Celsius. A paste type material is obtained that is called mud. Now, digestion with water and cooling at 100 degrees Celsius. Boiling, then cooling. Now, residue is separated from the filtrate. The filtrate contain hydroxide, phosphate, silicate, etc., while the residue contain our desired components. Hydroxides of lanthanides, thorium oxide, titanium oxide, zirconium silicate, or zircon, it is also called zircon, etc. Now this material, this residue is treated with HCl and heated. What happens? Titanium oxide and zirconium silicates are insoluble, while other thorium plus 4 ions become soluble. So here again, the filtration process can be used to separate the residue and the filtrate. The residue contain titanium oxide, zircon, etc., while the filtrate contain the lanthanides plus 3 and the thorium plus 4 and other ions are mentioned here. From here, the thorium plus 4 can be separated, removed. And now this mixture, this filtrate can be used for the separation of individual lanthanides by using any suitable method which has been discussed in previous lecture, such as ion exchange method, solvent extraction method, chromatographic technique, etc. All these techniques can be used depending on the suitability. Now modern method, ion exchange method. In this method, the ion exchanger is packed in a column. The ion exchanger usually contains these groups, SO3H, COOH group. The H of these groups are replaced by, substituted by the lanthanides ions which have L are represented by Ln plus 3. When the solution of lanthanide is added in column containing the ion exchanger containing the function groups SO3H and COOH, the lanthanide ions replace the H plus of SO3H and COOH and get fixed on the resin. Check here a simple representation. Lanthanum plus 3 in water solution is added in resin, which is represented by 3HR. Now what happens? Lanthanum ion get replace the H plus of resin and become LNR3 solid plus 3H plus. We know that lanthanide ions with different sizes have different sticking ability on the ion exchanger, which is packed in column. In order to remove lanthanides plus 3 ion fixed on as LNR3 solid on the resin, the column is leached with the complexing agents in eco solution, like buffer solutions of ammonium citrate and citric acid, depending on the suitability. Ammonium citrate and citric acid buffer solution is mixed in water and added from the top of the column. Such complexing agent called eluents or eluates or eluting agents. These eluting agents separate the ions from the ion exchanger, which is packed in the column. The column contains ion exchanger, and we have added the lanthanide mixture, lanthanide ions mixture, which bind to the ion exchanger. Now from here we add the complexing agents such as ammonium citrate and citric acid. And these ion moves travel at different rate downward depending on the firmness of the ion or attachment of the ion, degree of attachment of the ion with the ion exchanger. During eluting process, ammonium ion of the eluting agent replace lanthanide ions from LNR3 to give lanthanum plus 3 ion, which reacts with citrate ion to form the lanthanide citrate complex. And this lanthanide citrate complex begin to travel downward. Check here, lanthanide plus 3 citrate ion, lanthanide citrate complex. Now, the lanthanides ion which are attached to the resin have different firmness. The ion which have minimum firmness attachment, adsorption, attachment will come out first, and the ion which have maximum firmness attachment with the ion exchanger which is packed in column comes out at the last. In this way, all the fractions, all the type of ions depending on their size and firmness can be separated, can be eluted one by one from this area, from the outlet of the column. By using this method, 99.99% pure rare earths can be isolated. It means this method has extraordinary efficiency. Now, the solvent extraction method, which is also a popular method and modern method for the separation of lanthanides. In this method, separating funnel is to be used. For example, it is separating funnel, water containing the lanthanides compounds which are soluble in water. Now the kerosene oil having less density than water and form a separate phase on above because it has less density, water has more density, and the solubility of lanthanide in kerosene is much more as compared to water. So lanthanides compound go into the kerosene. So by separating the kerosene layer, we can separate the lanthanides. Now the detail. This method was first reported by Fisher based on the difference of solubility of lanthanide salts in water and immiscible organic solvents such as kerosene oil. These organic solvents are called extracting solvents. Extracting solvents always have more solubility for the components which are to be separated from the aqueous solution. This method can be used at micro and macro level, on small scale and large scale both, and highly sensitive method. In this process, the aqueous solution of lanthanide salt pass through the organic solution in which lanthanide extract from water. The most widely used extracting solvent is tri-N-butyl phosphate, TBP. In an inert medium like kerosene or xylene to extract the lanthanides. It means our kerosene oil, that is organic solvent, it contains the TBP for the extraction of the lanthanides from the solution. TBP form complexes with lanthanide and N plus 3 cosine in the presence of nitrate ions. Here the complex formation has been shown here. It is complex. The central atom, the ligands which can form coordinate covalent bond with the lanthanides. And the organic means the organic phase. It is formed in organic phase. The distribution between these two phases, both solvents which are immiscible water and kerosene oil containing the TBP, the distribution between these two phases is described by distribution ratio lambda given by total concentration of solute in one solvent and total concentration of solute in other solvent. And usually the organic solvent is taken here and water is taken here. Now check the formula. Concentration, C means concentration, C means concentration. Read it, write it, memorize it. Now, continuous counter current extraction process by using the solvent extraction method. How? Repeated again and again, and how to get the concentrated lanthanide compounds mixture from which the lanthanide can be separated by using the other methods. How it can be done? It is a feed. The mixture is added here. Extraction unit. Solvent is added. Extraction occurs. Stirring occurs. Mixing occurs. Now, loaded solvent here, containing the solvent here. Now, solvent recovery, solvent losses, and the recovery of solvent, the recovered solvent again recycled. And by repeating this cycle again and again, the solute in concentrated form, which is to be accepted, is separated. Now check the formula again. Values and alpha, concentration of all the things are given in expression number 2. Peppard has reported that an average separation factor for adjacent lanthanide is 15.8 molar nitric acid minus 100% TBB system is about 1.5. It means the separation factor is good, which is needed for the separation of all the lanthanides. Now the equilibrium constant, distribution constant, partition coefficient is given by K. These things which are present in organic are to be separated, these things, and these are those things which are in usually equal solution, which are to be separated by using the organic solvent. Combining the equation number 3 and equation 1, on solving the equation we get the lambda is equal to K, distribution constant, concentration raised to 3 of nitrates of lanthanides minus concentrations power 3 and TBP in organic. Kilogram quantities of 95% pure lanthanides have been prepared by solvent extraction technique. Another organic solvent which is better extractant than TBP is di-2-ethyl hexyl phosphoric acid. It can also be used nowadays. This solvent is used as extractor. The major uses of solvent extraction process for separation of lanthanide plus 3 from lanthanide plus 4 ions such as cerium plus 4, thorium plus 4, and in the purification of cerium, thorium, lanthanum can be done by using different methods. Now, the acid dissolution of bastanosite and alkali digestion of monazite xenotime is discussed in Flowsheet diagram in a brief manner. What is to be done? Bastanosite, following steps are to be done. Mineral dressing, which have been discussed in lecture part 1. Dissolution of calcium carbonate and 10% HCl. Oxidizing roast, conversion of cerium plus 3 to plus 4. From here, the CO2, HF and SiF4 separate out. Now, the remaining material is treated with concentrated sulfuric acid at 200 degrees Celsius, dry product by heating at 100 degrees Celsius, leaching with water. After leaching, we get the following things. Solution of light lanthanum and lanthanide sulfates and cerium oxide solid, and little thorium or heavier lanthanide are also separated from these this portion. From this portion, we separate these two things, light lanthanides and heavier lanthanides. The next is the extraction of lanthanide from mineral, monazite and xenotime, these are the minerals, by alkali digestion method. Check here, monazite, xenotime, mineral dressing is required, that is crushing, grinding, hot froth flotation, etc. Then the digestion by using 140 degrees Celsius and 65% NaOH, and extract phosphate with water. Slurry, paste-like material of impure hydrous oxides of lanthanum, lanthanide, thorium obtained. Now boil with HCl at pH 3.5. Impure solution of lanthanum, lanthanide chlorides are obtained. Now add barium and sulfate. The solution contains lanthanum, lanthanide chloride, which is separated out, and the precipitates are separated out, which contains the radium sulfate, etc. Thank you very much. Read, check, listen again, and then make your flow sheet diagrams to memorize and to reproduce. Thank you.